Check. Yeah. Check. Check. Okay, great. Should we start then?
Yeah, if everyone's ready. People still come in. Maybe start the tune.
Okay. All right, should we start then? All right. Sound. Sound. So what you saw was Jugalbandi between two masters, and actually that really inspired me. And I said, you know what? What if I change the context of this and instead replace music by code, replace instruments with languages, and here we are with Code Jugalbandi. Yeah. So I'm thankful to Functional Conference and Naresh to provide this opportunity to debut this experiment. And I'm thankful to Jaideep as well. We have codejugalbandi.org site up and running in just about a day's time. And so I would like you to meet Ryan.
Hi, everyone. Yes, we've been jugalbanding for a few months on functional programming. In fact, we started exploring it together, trying to just kick around some ideas in these different languages. We came up with a whole bunch of melodies. All of them are on the site. But we're only going to do a few today, and it'll be just little abridged versions of what is online. What we'd like to share most of all is the dialogue of it. This is not a combat, this is a conversation. And it was a really playful way of exploring and learning. So we're just going to do 3 melodies today. The first one, since we're talking about functional programming, is about lambdas, because everything is a lambda. So in functional languages. So let's start with that and kick it around in a few languages. We're going to be using Clojure. I'm going to be using Clojure, a bit of Haskell. Dhaval's going to be using Scala and a bit of Groovy and anything else?
No, not today.
Okay, so we're just going to show you some basics, just in case you don't know Clojure. It would be a bit of a nuisance if you didn't know what we were doing. So I'm going to just show you some basic elements of it, which makes it unusual from a non-functional paradigm point of view.
It's not visible.
Oh,
Sorry.
mm-hmm.
Why is it? Oh gosh, but this is not to be extended. Sorry. Sorry about that.
So that should give it away. I'm going to define a hash map object. So that, let me just do a coordinate. X is something, and Y is something else. Now, the one thing I want to show you about this is that if I wanted to get at the key, the x value, I can take my hash map and apply it to the function. And, great, thank you. And there you go. So the point I want to make is that a hash object in Clojure is a function. It's not an object. It's a function that you can apply to its keys. Similarly, an array in Clojure, this would be called a vector. But just to keep it simpler, I'll call it an array. And similarly, I can say, take this array and give me the 0th element. So this is already interesting, quite an interesting difference from object-oriented languages. So let's see that in Scala.
Sure. So in Scala too, a map, for that reason, is a function of its key. And I could just say x pointing to, say, 1, y is 1, 2.
Same thing.
Same thing, yeah. And let's look at a vector. That's the same thing. So both are similar in that. What about functions, Bert? No, 1 and 2 elements in there. So if I did this, that would get 3. So that's a vector is a function of its index, and a list is a function of its index, and so on and so forth. That's an index, function of its index.
The array index.
Yeah. Should we look at functions? Yeah.
Yeah, great. So I'm going to write a lambda in Clojure. So a raw lambda looks like this. I'm going to just find a square function, and I'll call it a square lambda, square L. And the syntax looks like this. It's an anonymous function that takes something and multiplies it by itself. Note that in Clojure or any Lisp, we use prefix notation, so the operator comes first and all the arguments follow. Same thing with def can be seen as a function applied to operators, although these are actually special forms in Clojure. If I wanted to do this, so let me just prove that little function. So there we go. And if I wanted to define an explicit function, there is syntactic sugar. It's called defn, define function, which looks ever so slightly different. It's more compact. So it looks like this. I can directly define the argument list and again say that you should be returning x times itself. And that should be easy to prove. The point is that in Clojure, everything is a lambda underneath, and the defined function is just a macro or a special form that is actually syntactic sugar and reducing to a lambda underneath. Now that I have a lambda, whether it is a lambda or a function, doesn't matter. I can map any of these to my array, and that should be like that. So that's how a map works. Let's do that in Scala.
Sure. Well, in Scala, it's kind of a bit different. Let's say we have a square method, and it takes x, and it's going to return x times itself. So that's how I'm going to run Scala code. I could also define function as an object, and this is where I define lambda. Square goes, it consumes an int and produces an int, and that's the signature. And so we get.
How does it understand when the function ends?
Oh, that's just the syntax. It's equal to, and this is a one-liner function. So
And if it's a multi-line?
you just put braces in, and you go ahead. So this is in Scala, but the interesting point to note here is, like, let's say what's the type of this chap here? You know, when I run this, I get function one. So it's a function as an object here. But if I try that for method, right, what I get is missing arguments for square method. Follow this by a dash if you want to treat it as a partial function. It's being cut out here, but yeah. So a method is not really same as a lambda, like what you're seeing in Clojure. If I have to do this and convert this into a function, I would just put a dash as recommended by the Scala compiler, and then I get function one back. So I could then basically take this into, let's say, square 2. Of 3. And just like how you mapped all the collections, in Scala, I could also map, let's say we have a list going from 1 to 3. I'll just keep it simple. 2, 3. I'll do a map, and I could then pass in either a square method or a square 2. And I get a list of squares. What happens is underneath the Scala compiler is literally doing what we see here on line number 10. It's converting it to a function. I guess that's the idiosyncrasy of Scala. That's that's the way it is implemented. So that's we can see those two distinctions very vividly here in Scala, whereas in Clojure it's kind of seamless. You pass a function, or you pass you pass a function name, and then that's pretty much it. Do you want to Haskell around?
I'll do it in Haskell because we're going to Haskell a little bit, and this is the introductory melody. So let's do it like this. I'm just going to define a lambda. Venkat made a good point this morning that you typically don't lambda much in Haskell because it's so purely functional that the reasons aren't as don't really exist in the same way. So that is a lambda function, and I can actually apply that to a number like that. I'm not going to run this Haskell, but I'll just show you also the square of x. I could then just define as x times x. So that's as pure, close to the math as you can get. And of course, in Haskell, it's lambdas all the way underneath.
Cool.
So let's. I think just finally on that melody, whatever language you're working in and whatever language you're using to explore functional programming, figure out what's going on with lambda. Is lambda for real, or has it been tacked on later on a higher level, or is lambda fundamental? Is it actually the bedrock of it? Great. So let's finish that one off.
So that's the finale. I'm just kind of showing the code here in different languages that we showed. Probably we didn't try Groovy, but that's what it looks like in Groovy, how to define. Cool. Should we move on to the next melody then?
Yeah.
Okay. So we are done with everything is a lambda. Next we're going to talk about is currying and partial function application. Yeah. For a change this time, I'm going to look at Groovy. Let's assume I have customer object to be fetched from a repo in a typical web application scenario. And that customer is authorized. I mean, we need to make sure that the request is authorized. Yeah. So typically, let's say I would define HTTP request. This is, by the way, a map in Scala. Obviously, the request arrives as a string, but I'm just for sake of convenience, I'm going to do a string and a int map. Yeah. And then I want to authorize. Assume I have a repo, and then this is the HTTP request that kind of goes. So what I'm going to do is I'm not going to sit here and write repo. Instead, I have a pre-baked code, which I'm just going to plop in here. Yeah. So as you see, it's a typical repository containing a find by ID. If ID is less than 0, throw an exception. Otherwise, return a customer as a map, wherein we are returning ID and the name of the customer. Obviously, I need to instantiate this repo. I have the customer repo now ready to go, except that now I don't have the authorize function defined yet. So what I'm going to do, I'm just going to define the authorize function as a closure here, which takes in repo and a request. And then, after it gets the request, it needs to suck out the ID from the request. And obviously need to validate or authorize whether the person is, whether the request is authorized or not. So I'll just say auth here, and then it needs to get the repo dot find by ID. And it should return you a customer object. So there we see it's returning us a customer object at this point. It's at the lower bottom. Maybe I should just get rid of, sorry. Okay. What if I have another request, coming in? Let's say ID 2. Let's call this as request 2. And then pass in request 2 and get customer 2 customer 2.name. So obviously this works, but we see this this duplication here, right? I mean the repo which is kind of fixated is over here. Normally in object-oriented programming, we encapsulate what varies. Here, the repo is kind of staying fixed, and the request kind of varies. I'm kind of asking myself, what if I am able to reshape this authorized function that is converted from a 2-argument function to a 1-argument function, so that the varying requests can just come in, and this can still work. So for that, Groovy provides you currying. Currying essentially returns you a single argument, a function with a single argument. So I'm going to curry this particular parameter. The return of this is going to be a function. So obviously then I can use the HTTP request coming in this fashion. Yeah. So I'm going to do the same here for the second one as well. And just yeah, because currying returns a function. So it has taken in repo, and I'm reshaping the function now. So it was originally a 2-argument function. I'm now converting it to a single argument function.
That's how you apply the value to the function?
Yeah, so this is like our normal function application. If I extracted this bit out, yeah, into a, let's say, a auth function, right? then you only see auth. I don't need to pass this. Yeah, if that syntax helps. S- Yeah. Currying, I'm just reshaping the function, whereas in find by ID, the argument is just one and it's fixed. I want to now.
If your repo is not changing, then you can, if your repo is not changing, then you can make it as part of your inside the function only, right?
Yes, I could. I'm just showing you here an example as to how I'm going ahead and reshaping things. Yeah?
And it's often useful for when you're not the author of the function, or it's a function that you're getting, you're inheriting. It's something that someone else wrote or that you wrote 3 weeks ago, same thing almost.
Okay.
And you're kind of now taking that existing function, which is quite useful in that form, but for this purpose, you just want to reshape it.
And to take it further, let's say if I want to now authenticate, now I've authorized it. What if I want to now further, let's say, authenticate as well? So I'll just write, let's say, authenticate as a closure, but before that, I would like to authenticate what I'm authorizing. So I'll say authenticate, and I'm just, authenticate what? So I'll just right now write a closure here. It's going to take authorizer. It's going to take in authorizer, which is in its curried form, and it'll take in a request. Yeah. But you see, again, I'm running into this problem. If I want to use authenticate is if it takes in curried closure like this, what happens to the request? And obviously, in this piece of code, I need to make sure that I apply auth curried is also a function, just like we saw early on, and I pass on request to it. Yeah? And here, I need to curry it further. If I just did this, this is now going to go through properly. Because it was originally, again, a 2-argument function converted to a single argument function. So we are reshaping function, and request is kind of flowing through these functions as a one single parameter. So this is really currying. And if you look at this and you say, all right, how does it look in Scala? So I'll just kind of open up a code here and show you currying in Scala. And very quickly, this is the case class customer. This is our usual repository. In Scala, instead of throwing an exception for an absence of value, you normally return a option. So it's either some value or none. So that denotes absence and presence of a value. I have the request, which is kind of string and map. And this is where it really gets interesting. Note this kind of syntax. We early on saw that in Groovy, didn't we? And Scala says, you know what? I'm going to take this syntax, and if you write functions in multiple parameter list, I'm going to give you currying for free. So you don't have to do .curry. Just write functions like this, and you get currying for free. Yeah? And then since it's a method and we did partial function application, I just kind of convert it to function as an object. And then if you look at this line, that's the line in Scala. No .curry like what we saw in Groovy. How does it look in Clojure? Let me just get some
very
stuff,
nice in Scala.
stuff out of the way. Yeah.
So Clojure doesn't have currying. I mean, we've been using the term currying and partial function application. Those terms are often mixed, and I'll use the Clojure to draw a distinction between those things. So in Clojure, let's say I had a function that creates a new person. And it takes a title, a first name, and a last name. And it will create a hash map for me. So I'm keeping the structures very simple, as one does in functional programming. So I'm going to create a new person, so to speak. And let's call her Miss Ada Lovelace. And let's do that. So there we go. Now let's say I have this function and I want to apply one of these arguments. So I want to create a function now that instead of creating a new person, creates a new miss. And I will just pass. So the title must be wired in, just like you were wiring in things. And I just want to pass in the rest of it. So I'm going to say new miss is a function. And I want to do something like this. I want to say the first parameter is going to be that, and the rest, just defer it for now. And in Clojure, you would do this to say, partially apply this function to the following arguments. So partial says that I'm not going to give you all the arguments, but give me a function back that will take the remaining arguments. So now if I create a new miss, same thing. So partial function application and currying are different in this way. With currying, we're talking about a function being a function of one argument at a time. So when you did that Scala, there was parentheses for the first argument, another set of parentheses for the next, meaning you were explicitly saying, make this a function of a function of a function. A function that takes an argument returns a function that takes an argument until you run through them all. And so the way I think about this is it's almost like, you know those little Russian dolls. You get a tiny little doll and then you get a bigger one around it. You put it in a bigger doll and so on. And you get this nest of...
so until you exhaust them all,
yes.
you don't get to the meat.
So with a true curried function, you're not getting one function. You're getting actually a nest of functions. That's one way to think of it. In Clojure, there is no currying out of the box, but there is this partial function application. Now let's see how useful this is for. Let's say I wanted to make a new function that doesn't return a new miss, but returns a new ADA. So now I'm going to say, I don't want to actually say miss ADA. I want to not pass that in. And so this partial function application is failing me now because it works nicely if I'm wanting to fix in the parameters, the leftmost parameter, and then the next one, and then the next one. But this isn't helping me now. So of course I could always write a function a new function that would use the old one and do it for me. So you can always write if you never had currying or partial function application, which probably you didn't if you were in a OO-ish language, you would be writing a lot of procedures to reshape existing procedures. Whereas in this case now, there's a syntax in Clojure. It's called literal function syntax, I think. And then I can say something like this. I can say, I don't know what the first parameter is going to be. I don't know what the last parameter is going to be. But there is ADA, and that's the only thing I know. Okay. And then if I say new ADA, I should, okay. So with this, this is kind of giving you, this is a macro, by the way. It's a synthetic partial function application that allows you to, in an ad hoc way, wire in params. Currying doesn't work like that. Currying forces you to go from left to right. Partial function application forces you from left to right. This is a more powerful technique. I'm sure you have this kind of thing in Scala.
Yep. The way partial functions are in Scala. That's
So I'm just going to get rid of all this here. Okay. So let's say I want to have a function salute, and the title is a string, and f name is a string, l name is a string, and I'll just define it to return a string. By the way, this is just a string interpolation. $title dash $f name dash $l name. And if I wanted to say do something like what you did here, in the sense fixate the first the title, right? So in Scala, I would just say salute miss. I'll wire in miss as the first parameter, and then I'll put placeholders for the functions, for the parameters which are to be bound at a later point in time. Yeah, underscore is the Scala thing for placeholder. So it'll understand.
It's a special
Yes. So it's salute miss. Yeah, that's the part. Scala doesn't infer. Yeah. So we'll
That's
go.
what Haskell is for.
There we go. And if we wanted to fixate Ada, so I'm just gonna grab the stuff down from here, say Ada, and this time around, I just want to do this instead, do this. Just gonna copy the code. I don't know if there was a Mr. Ada, but there we go. So
It's quite easy then. Beautiful in Scala, actually,
It's-
except for the types.
it's just uniform, I think, unlike the other closure example that we saw.
Nice. Well, yes. So I would say, I'll say it like this. If you never had currying and you had partial function application, like in closure, you don't miss currying because you can do all of it with partial function application. And if you have currying, you could, do without partial function application. So my view of it is that while these things are quite different under the hood, from a practical point of view, you just look for whatever functional programming language you're in. Look for the thing that is going to, even Ruby has currying in the same way as Groovy. You say .curry. And yet, I can almost assure you that, well, in Ruby, I can tell you there isn't really currying. They're just using the term because partial function application is too long. And same in Groovy. I wouldn't be surprised if that's partial function application under the hood. So I would say use what's available. Different languages are going to give you a different tool to use. So in Clojure, I would use that literal function syntax quite a lot. I wouldn't even bother, quite often I wouldn't bother with partial function application. Whereas in Scala, you're going to be doing a lot of currying there, or partial
function, depending on the context. If I don't want to convert back and forth, why just not use this directly?
Yeah.
And in
I think currying is also, if you only need currying, if you want to do just the first parameter, currying is more concise and clear. Partial function application always comes with its own, whatever syntax the language designers had to concoct to make it happen. So with currying, there is something more pure and simple about it.
Yeah, so whenever you have simplicity, I mean, Scala offers you both, right? So whichever describes your situation best, go for it. And one more thing just to mention further is, in Scala you can convert between forms, between the curried form and the uncurried as well, and then, go ahead. So yeah, so that's what it is. How much time have we? Do we want to Haskell around a bit, or?
Yeah, let's do a bit of Haskell. I'll just show you this in Haskell. In fact, Venkat showed that quite nicely a little bit, but I want to just go a little bit further with that. And so let's say that I do have a make person function, and I take a title, first name, let me just not clash with anything there, and last name. And I'm going to just be lazy now, and not lazy evaluation, but lazy in the normal sense of the word. And just do that, and then I'm going to print new person. Okay. Now, in Haskell, I'm going to just put the type signature in there. It was inferred, so we didn't have to type it in, but I'm going to type it in to make it a little bit more clear what's going on. So this says, this is a function, type signature follows after this. And this signature is a string title. So it's a function that takes a string, that returns a function, that takes a string, that returns a function, that takes the last string, the last name, which then in turn returns a string. So that's the type signature for that. And so in Haskell, currying is built in. Any function you define, unless you use a tuple and explicitly say I don't want currying, you're going to get it. And so to prove that to you, I'm going to do that. So I'm going to say make function miss, applying the first argument, is giving me a function which will then take these two. So that still works. And then I can go even a little bit more crazy and say, well, that function, this one here, is a function which takes another parameter, and so on. So that might be, if you haven't seen that kind of thing before, it's a little bit of a mind bend, and I encourage you to kick around the code afterwards. But if your mind is a little bit bent by it, then good, follow that up. So that's currying for real. That's as pure as we're going to get it in math, almost.
Right, and I think we have to decide whether it's orderless application, go for partial functions, depending on the language that you are in, and if it's just left to right, go for currying.
Yeah, I think one last thing to say is that partial function application, ad hoc argument, wiring in arguments ad hoc, is practically much more useful than currying. You sometimes need to work harder to do ad hoc function application. So I think let's wrap that one up.
Okay.
What's the next one?
Next one. So we saw currying and partial functioning, function application. Let's look at sequencing now. Okay.
Yeah. So yes, sequencing.
Closure first?
Closure first.
Okay.
Sequencing is something that we chose to include in this talk because it's the kind of thing that if you're getting into functional programming, you won't do this unless you know you can. So I wanted to just do this in a few languages, and that's why we wanted to include this. So goodbye with all those things. So what I'm going to do, I'm just going to check something, and if it doesn't work, I'm going to abandon and take another course. And so I'm just doing a little bit of setup. You can ignore that. And so now I want to do something like this. I'm going to do a bit of string manipulation. And I want to first define a few words that I'm going to be manipulating. And the words will be something from a poem I liked, like. And we're going to split those words on space. So I'm going to use a split function. Split using, this is closure syntax for regex. I'm going to split on space. And I'm going to split the words like that. And let's see if we, whoa. Okay. Cancel this. I'm going to just be a bit more verbose. I couldn't quite get it working in this environment. Lovely. Let me just find my feet. Sorry.
There's this, you can paste the code if you want.
That's strange. What am I missing? Okay, where's my closure peeps? No. What am I missing? Oh, do you mean this one? Yeah, no, that's actually good in closure. It does that. I'm just actually not entirely sure. No. Let me just do one little thing. If I don't get this in a sec, we'll. What a ball.
Maybe we can take a look at this code that you said.
Yeah. Maybe you can scratch around. I'm going to keep the narrative going and then we see if we catch up, okay? Because what I want to do is I want to define a function that is going to do some work in a nested way. Oh, am I just getting it wrong? Let's see. I don't think so.
Thank you.
Who said that? Thank you. You're a good person. So I'm splitting these words on that regular expression. I'm going to do a few things now with it, and I'm going to, on purpose, be a bit ridiculous about it, because I want to show you sequencing, really. And that will take words, and then we're going to just do that. So I'm going to add a few things. So let's say I've done that, fair enough, but I actually want to do something else also. I want to capitalize all those words. So I want to map the capitalize function to this split string. So I'm mapping this function to the vector returned by the split string. Now let me do another nest. I'll do one more and then I'll stop. So let's say I want to filter this now. So I want to filter this with some lambda that takes a word and maybe discards all words that have a size of the word that is, less than 3. And then I'm going to apply it to that. So as you can see, this is not very nice.
Should we use less than equal to 3?
Yeah. Yes, thank you. So if you're getting into functional programming, you're going to be finding yourself nesting up a storm. You're going to be nesting and nesting and nesting, and you're going to get completely in a straitjacket eventually and go back to object orientation. But I want to show you an alternative to that. I want to grab that code from our thing here, and I'll show you the next iteration of that. So we have that now. Ugly, very ugly. The next best thing I can think of is to use composition. And using composition, what I'm doing is I'm saying compose. So there's a bit of a syntax noise here. I'm assigning something. I'm saying let f be something. So I'm saying let function, so that I can later say f words, function words, apply function to words. So I'm saying this function is a composition of this. We need to read it from the bottom. Just as we did with this nest. The first thing we did was split. The next thing was capitalized. The next thing was filter. And yet we need to write it the other way around, which is awkward. So if you find yourself doing that, keep searching. So the next thing you could do, the next thing to tighten this up a bit, and as they say in closure, parentheses are smell. So we want to reduce the code smell, and we are with composition having a bit less parentheses. But what I'm doing now is I'm saying, there's my lambda. There's a lambda that will split the words. The next thing will be capitalization. The next thing will be filtering. The next thing, finally, I join those strings. And so you can, instead of nesting, you can always compose. But you're still stuck with this situation where the order is different to what you're actually thinking, which is annoying, because when you're writing, you have to reverse your thoughts, and when you're reading it, you have to reverse it. And so when you do that, if you do that in any functional language, don't. Keep looking for the way in that language to not do that. So I'm going to show you how to do it with using this arrow syntax. It's a syntactic sugar for really, it's a macro, and it gives us this composition, but in the correct order, in the same order than we're thinking. So let me just show you that. Where are we? So now I can get more serious about the order as I think it. So I'm going to say, let's say that I take these. Let me just get this right in the middle for us. Let's say I take this string, this words string, and I split it. So for now, ignore that thing. We're going to say what it is. So string split, now I've got my original split words that you saw earlier. And now how this arrow works, because it's a double arrow, it means this. It means take the result of this first step and shove it into the next part of the pipeline, really, the sequence. And so remember, I had partial functional application here. The macro is smart enough to actually take care of that for me. It's using that literal function syntax, so it doesn't use partial function application. So, or not proper partial function application. So I'm saying map, capitalize, and how this syntax works, it takes a little bit of getting used to, but once you do, you'll completely be blind to it. But what's actually happening is it says, where I made this X marks the spot where the result of the previous line will be inserted. So it will take this and it will calculate the array and shove it in there. I'm going to remove, I'll keep it in there for now, but it won't run, but just for to make it more understandable. Same thing with filter. I'll do one more step. Same thing here. I don't need partial, and I can just apply my function. And again, it will take the result of the capitalized words and shove it into the last position of the next function. So this looks a bit, it looks a bit crazy, but the great thing about it is you get the order you want. And if you get used to it, you'll find that so much of what you do is a sequence operation. So let's see that in Scala.
Sure.
So I'm going to borrow the string which you have. So I could straight away, do pipelining or sequencing here. So I will say words dot split on space. This gives me a sentence converted to words, an array of strings. On that, I'm gonna now say map, and I'm gonna get a word at a time. On that word, I'm going to say 2 uppercase. I'm just going to convert the whole case instead of capitalizing. And then I'll say filter. Let me just kind of chain it in this fashion and put it here. And w dot length less than equal to 3. And I'll need to get it in it's an array, so in order to make it print, I'll need to join it. So I'll use mk string in Scala, which would just then join. Let's say I join it by, you've used \n, new line?
Yeah.
Okay, so I'll just stay consistent with your stuff. In this case, I've just capitalized everything. So this is how, I'm doing chaining. But, we could do composition, as Venkat said in his earlier talk. Try to find functions and then, then try to use them, later on. So then I'm going to go into the world of composition here. So whatever we see here, I'm going to split it into smaller functions, let's say. The first one I'm going to say, I'm going to split here. Split, in this case, I'm going to receive a string. So I'm going to call that sentence as a string. And again, I'm writing lambda. So I'm just going to say s dot split on space. That's my first function. Second one, I'm saying capitalize. Now, I'm going to get array of words out of this. So I'm going to say array of strings, So I'll just say words is an array of string. And I'm just going to say, I'm just going to use the shorthand form now. It takes that first argument and directly calls. So it's available to you as the first argument. If you have more underscores, it applies the first, second, and third in that order. So it kind of makes your code short. So this, what you see here, that's the shorthand over here. It's pretty much the same. Yeah. So again, I'm going to copy this signature because I'm still going to get array of strings out of this. And I'm going to say words dot filter. I'm going to go for the shorthand form less than equal to 3. Apply the first argument, and on that I'm calling the method. That's exactly what it is. And then I'm going to say join. Again, it's an array of words, and I'm going to say yeah. Now, how do I enter the realm of composition in Scala is, all I do is I say, well, let's say this is composed sequence, and I'll like what you did here, when you enter this composition, you have to work against the grain of thought. So that similar thing is kind of there. So I would say join, compose, filter, compose, capitalize, compose, split. So now I've got a composed function on that. So if we just compose sequence, if I just run it, it should give me function 1 because it's taking in one parameter. So all I need to do now is, to this compose sequence, I need to pass in the words that I defined early on, and that's what we get. But this is not that great, right? How about if I take this and make sure that it kind of works with the grain of thought? So instead of looking from right to left and building up the thing in your head, we are used to doing from left to right. So I would just say split first and then, capitalize. Oh, sorry. And then filter, and then join. So this is again, if I run it, I get function 1. It's a single function, and just pass in words to this. And there we go. So I think this works more with the grain of thought, not against the grain of thought. So I would prefer and then in this situation. And just to show you, I don't have time as we are running out of time. I'll just pull up some groovy code here. And if you look at this code, that's exactly what's happening. Instead of Scala's map, we have collect. Instead of filter, we have find all. And instead of make string, we have join. Yeah? So that's just the mapping. And I have then gone ahead and defined each of them as separate closures. So split is a closure, capitalize is a closure, filter and join, so on and so forth. And look at that. That is, I like this. This is beautiful. Shove in the output of this into that, into that, into that, into that.
Beautiful.
And that's the end then in Groovy. So if I just run this right now.
Haskell also,
Yeah,
in a similar way.
cool.
Great.
So
Let's call it a
let's call it,
Jugalbandi.
yeah, let's call it a Jugalbandi. That's it. We're running out of time. Questions? By the way, since we are not able to cover all of them, there is, you can go up, there are several Jugalbandis that are there on codejugalbandi.org. We saw just 3 of them: destructuring and pattern matching. Functions are entities, lazy sequences, referential transparency, expression problem, and recursion. So those melodies are up there, and those melodies are kind of